Hey everyone, in this video we'll learn all about inverse functions. So first let's talk about normal functions. Let's talk about a function f of x. So we have this function f of x, and just keep in mind that functions are like machines. So inside this function we put an input, x, and then the machine gives us an output, f of x. So a quick example, let's say that f of 2 equals 7. So that means as far as this machine goes, we can put a 2 inside of this machine, in this function, and it will give us a 7. So that is how functions normally work. And now let's go ahead and talk about inverse functions. So f inverse of x. So f inverse of x, that is how it is read, and it is written with this superscript -1 up here. And again, when you write this -1 up here, f -1 of x, this is read as f inverse of x. So f inverse of x is the inverse of f of x. What does that mean? Let's think of f inverse of x as another machine. We'll make it this red machine. This is the inverse function. So what we can do is we can take any output from f of x, we can put it in as an input into f inverse of x, and we will get an output out of it. So in other words, we can put a 7 into this inverse function, and we will get a 2. So that means that f inverse of 2, or f inverse of, rather, 7, f inverse of 7 equals 2. So if f of 2 is 7, right here f of 2 is 7, that means f inverse of 7 is 2. And that is how inverse functions work. So let's go through an example with a table. Let's say we had this table down here with x, and let's go ahead and just draw this table. So let me just erase that. So x and then f of x. So 1, 2, 3, 4 for x. 1, let's say it was 5. 2 is 7. Let's say 3 is 9, and 4 is 11. So we have this table right here for f of x. So how you read this is f of 1 equals 5, because according to this table, f of 1 is 5. And then you can read every other one. F of 2 is 7, f of 3 is 9, so f of 3 is 9, and then f of 4 is 11. So to write it down, f of 1 is 5, f of 2 is 7, f of 3 is 9, and then f of 4 is 11. So what does this tell us about the inverse function, f inverse of x? So let's actually try to draw a table for f inverse of x. What we can do is we can actually take this table for f of x, and we can just switch both of the columns. So let's go ahead and for the x values, for the inputs in our inverse function, let's take the outputs of f of x. So let's take all these numbers, 5, 7, 9, and 11. So this would be 5, 7, 9, and 11. And now for all the outputs of f inverse of x, let's take all the inputs of f of x. So 1, 2, 3, and 4. So let's write that in, 1, 2, 3, and 4. So this means, if you read it, if you read this table, f inverse of 5 is 1. So we can write that down first. F inverse of 5 equals 1. F inverse of 7 is 2. F inverse of 9 is 3. And F inverse of 11 is 4. So we can write those down. So F inverse of 7 is 2, f inverse of 9 is 3, and f inverse of 11 is 4. So it's the opposite of these ones right here, where f of 1 is 5, f of 5 is 1. F of 2 is 7, f inverse of 7 is 2. F of 3 is 9, f inverse of 9 is 3. And f of 4 is 11, f inverse of 11 is 4. So that's how an inverse function works on a table. And that's what an inverse function does. So now let's talk about an inverse function algebraically. So let's say f of x, just normal f of x, equals 2x plus 3. So how do we find f inverse of x? What is this equal? So what we're going to do right here, we're going to go through a few steps to find the inverse function of f of x. So step 1, we are going to set f of x equal to y. So this will simply be y equals 2x plus 3. That's step 1. Now step 2, what we're going to do is switch the y's and the x's. So all the y's will become x's, and all the x's will become y's. So this y right here, it will become an x. So that will become an x. X equals 2x. So instead of this x will become a y. To y plus 3. So that's the second step. And now the third step, right here, is we are going to solve for y. Solve this equation for y. So we're going to isolate the y right here. So let's go ahead and just write the equation this way, 2y plus 3 equals x, just so y is on the left-hand side, so that when we solve it, it'll say y equals. And we'll solve it like a normal equation. We're going to go ahead and isolate y. So to do that, we can subtract 3 from both sides. And then we have 2y equals x minus 3. And then to solve for y, we can divide both sides by 2. And we are left with y equals x minus 3 over 2. And then the last step is we are going to substitute y for f inverse of x. So this is f inverse of x equals x minus 3 over 2. And that is the inverse function. F inverse of x is x minus 3 over 2. So the answer up here, f inverse of x is x minus 3 over 2. And that is the inverse function's formula. So if f of x is 2x plus 3, then f inverse of x is x minus 3 over 2. And we can test it with with one value. So let's say we wanted to find f of 1. So f of 1 equals, so we know f of x is 2x plus 3. So f of 1 is 2 times 1 plus 3. And what's 2 times 1 plus 3? That comes out to 5. So f of 1 is 5. So since f of 1 is 5, then we expect f inverse of 5 to be 1. So let's test that. What's f inverse of 5? We know f inverse of x is x minus 3, according to this, or x minus 3 over 2. F inverse of x is x minus 3 over 2. So that means f inverse of 5. So f inverse of 5 right here is 5 minus 3 over 2. That is 5 minus 3 over 2. And what does this come out to? So 5 minus 3 is 2, so 2 over 2, and that equals 1. And that checks out. F inverse of 5 equals 1. So that's what we have here. F inverse of 5 equals 1, and f of 1 equals 5. So these are inverse functions of each other, and that checks out. So that's how you do it algebraically. And let's go through a different example where we'll say f of x equals the square root of x. So f of x equals the square root of x, and we know its domain and range. So we know the domain and range. And let's actually say f of x equals x squared, and we know the domain and range. So we have this function f of x equals x squared, and we know that the domain of f of x equals x squared, this parabola right here, it's all real numbers. So negative infinity to infinity. We know that that's the domain. We can square any number, any x value works with this function. And we know that the range is from 0 to positive infinity. And that is because we know that this function right here can never be a negative number as far as real numbers are concerned. So we know that that's the domain and range of f of x, if f of x equals x squared. But what about for f inverse of x? So for f inverse of x, the domain and the range are actually flipped. So this is how it works. The domain for f inverse of x is actually the range of f of x. And the range for f inverse of x is the domain of f of x. So that means the domain for f inverse of x would be from 0 to infinity. And the range for f inverse of x would be all real numbers, negative infinity to infinity. So for an inverse function, all you have to do to find its domain and range, you just flip the domain and range of the original function. And that's how you find the domain and range of an inverse function. And now let's talk about inverse functions on a graph. So let's go ahead and draw a graph. And we will draw a graph like this. So 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4, -5, -6, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4. And let's say we want to graph the function f of x equals 2x plus 3. So f of x equals 2x plus 3. This is a linear function. So we know it has a y-intercept of 3. So we will go ahead and start at 3. 3 is up here. And we know the slope is 2. So that means the rise and run is 2 over 1. So that means rise 2, run 1. Rise 2 over 1, rise 2 over 1. And then backwards, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. There we go. Let's connect all these points with a line. And this is f of x equals 2x plus 3. So this right here is f of x equals 2x plus 3. Now, what is f inverse of x? How do we graph f inverse of x? So f inverse of x, what we're going to do to graph it is let's take a look at one of these points right here. So let's say 5, 1, or 1, 5 right here. So this point right here is 1, 5. So to transform this on the f inverse of x line, we are simply going to switch the x and y coordinates. So 1, 5 becomes 5, 1. So 1, 5 will be 5, 1, which is here. And we're going to do that with every point. So what is this? This is 2 comma 7. That becomes 7 comma 2, which is here. This is 3 comma 9. That becomes 9 comma 3, which is here. This is 0 comma 3. That becomes 3 comma 0. Negative 1 comma 1 becomes 1 comma negative 1. And negative 2 comma negative 1 becomes negative 1 comma negative 2. Negative 3 comma negative 3 stays in the same spot. Negative 3 comma negative 3. And then negative 4 comma negative 5 becomes negative 5 comma negative 4. And then let's connect all these points with a line. Just like that. So this right here, this is f inverse of x. And that is how we graph f inverse of x. All we have to do is take every point and switch the x and y coordinate. And as we saw in our example above, f inverse of x, so if f of x is 2x plus 3, f inverse of x is x minus 3 over 2. So this equals x minus 3 over 2. This green graph right here, this green line. And another effect that this has, whenever you graph a function and then you graph its inverse function, it has the effect of reflecting the function across the identity line. So let me draw and explain what the identity line is. So it goes like this. Let's go ahead and connect all the points of the identity line. So this orange line is called the identity line, and it is y equals x. This is called the identity line, the line where y equals x. As you can see right here, both x and y coordinates are the same for every point on this line. This is 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6, etc. That's why this is the identity line, because y equals x for every point on this line. So when we graphed the inverse function, this had the effect of reflecting the blue line. So we reflected the blue line over the identity line, y equals x. So that's what we did. We reflected this blue line. This blue line and this green line, they are reflections of each other about this line y equals x, about the orange identity line. So that is what graphing an inverse function has the effect of. So that is all we need to know about inverse functions. And if you have any questions at all, please leave them down in the comments below. I hope this video helps, and thank you for watching.